Hi everybody, this is Mark Schuyler. This is a video lesson on one of the 6 missing formulas that the test maker, in their wisdom, has decided not to give us at the beginning of each math section. We do get quite a bit of reference information, a lot of formulas there, but the slope formula has gone missing. We needed 2 to 3 questions on every SAT will be about slope, and it's not just enough to know the formula. Of course we need the formula, but there are at least 5 other slope related things that we need to know besides the formula. So what is the formula? Be careful you don't confuse the slope formula with the formula y equals mx plus b. That is the equation of a line, sometimes known as the slope-intercept formula. That's not what I'm after here. Today we're going to be looking at the slope formula, which is y2 minus y1 over x2 minus x1. And that equals m, the slope. Well, how many points do you need if you're going to find the slope of a line? One of the SAT's biggest tricks is to give what looks like only 1 point. And so I have students look at me and say, Mark, I can't figure out the slope of this line because they've only told me the point, I'm making this up, 8.3, and I need another point. Don't have it, can't give you the slope. Well, one of the SAT's big tricks is to run that line through the origin, in which case we do have another point. Remember, the origin is 0, 0. Well, the SAT likes to test the slopes of perpendicular lines. Many of my students need a little brush up. What are the slopes of perpendicular lines? If you know that they intersect at a 90-degree angle, then if you're told the slope of one of those lines, you ought to be able to figure out the slope of the other. Perpendicular lines have slopes that are negative reciprocals. And don't confuse that with this question. The SAT frequently wants to know what are the slopes of reflected lines. If one of these lines is the reflection of the other across either the x or the y axis. It actually doesn't matter which axis that the line is reflected across. Just think of it as this. That's the place where the line bounces or reflects, like a skipping stone. If you've ever skipped a stone on water, if you skip the stone in at a shallow angle, it tends to bounce up at the very same shallow angle. However, if you skip the stone at a very steep angle, it bounces up at a steep angle. That's very similar to what's going on with reflected lines. Well, they're always going to put an answer in that's a trap answer. If they want what are the slopes of reflected lines, you know that one of the wrong answers is going to be the negative reciprocal, what you would get for a perpendicular line. But reflected lines are just the negative of each other. They are not the negative reciprocal. So we don't need to flip the numerator and the denominator. We don't need to flip those. With a reflected line, you just have to remember if your original line is -2, for example, the reflected line will be +2, not +1/2. Of course, you're going to need to know the slopes of parallel lines. Most of my students know that parallel lines have identical slopes, just different x and y axes where they intercept, just different intercept points. And finally, I think it's critical to know what a line of slope 1 looks like. Slope 1, in my opinion, is the most important slope. It is sloping at a 45-degree angle relative to the x and the y axis. For example, if you were to draw in a line of slope 1 in the xy coordinate grid and you ran it right through the origin, it would be at a 45-degree angle and it would completely bisect quadrant 1 and quadrant 3. Remember, the quadrants 1 through 4, quadrant 1, very easy to spot. We usually work in quadrant 1, but they actually are numbered counterclockwise. So this diagram shows that clearly. So there we go. quick review, you need to know the slope formula, not confuse it with the slope-intercept formula. You need to know the slopes of perpendicular lines. You need to know the slopes of reflected lines and parallel lines. You also need to know that sometimes they give you a problem where it looks like they've only given you 1 point, when in fact they've run the line through the origin, so you have a second point, 0, 0. And finally, the importance of slope 1. We've covered that. It's at a 45-degree angle, and since many of the problems on the test are drawn to scale and you can trust the diagram, in fact, you can always trust the diagram unless they include that little note, not drawn to scale. But otherwise, it is drawn to scale. If you don't see that note, well, if you're looking at a line and it's really steep, there's no way it has a small fractional slope of 1/4, for example. A line that's really steep would have to have a slope that's greater than 1 if the line is more than a 45-degree angle relative to the x-axis. So that's the big review, and I hope that helps you get at least a 30-point jump in your math score, since slope is probably going to be tested 3 times. As a rule of thumb, every one more right on the SAT, one more question right, usually raises your math score 10 points on the scaled score. So 3 slope problems, that's at least 30 points. Thanks for listening.